Hi there, my name is Stephanie, and I did my project on the biomechanical differences observed in various contraction types. To start off with a little background info on the topic, the overarching idea is that not all contraction types are created equal. The predominant theory behind all muscle contraction mechanics is the sliding filament, or cross bridge theory, proposed in 1957. However, this theory fails to fully explain the observations seen in some contraction conditions, specifically eccentric. The limitations of this theory haven't been fully investigated until recently. So, the main purpose of this study was first to observe the muscle activation in two muscle groups during three different contraction types, and then further to propose some evidence based reasoning and clinical relevance or application for the findings. So our hypothesis was that eccentric contractions would require less muscle activation than concentric during isotonic conditions. And our sample consisted of 8 healthy Regis DPT students, 5 of whom were female and 3 of whom were male, all in their 20s. Our protocol consisted of 3 conditions: isometric, concentric, and eccentric contractions for both wrist flexors and extensors. And we followed standard EMG protocol for applying the EMG electrodes. We first collected maximum voluntary contraction using manual resistance in isometric conditions, which we used to normalize our data. And so I won't go through each of these, but you can definitely read the detailed explanation of each protocol. For our results, our hypothesis was supported. Eccentric contractions require less relative muscle activation than concentric. And these findings are supported by the literature. Herzog in 2014 and Power in 2012 both reported the role of titin and other passive structures in eccentric contractions. They presented evidence that titin increases its stiffness during active lengthening, and this expands on the two-filament cross-bridge theory. This has clinical implications that are twofold. First, it decreases the muscle activation required to lengthen slowly, which is beneficial for training individuals who may be neuromuscularly weak. Second, it results in a residual force enhancement that increases the force production of subsequent contractions, which could be useful when attempting max contractions. So in conclusion, I hope that this presentation was interesting and gave you some more information about the biomechanical differences between various contraction types and things not investigated quite yet. Thanks.